For this last one, your job is to use double angle and sum and difference identities, so what we did the past 2 days, and you're going to rewrite this expression so it's just sine of x and cosine of x. Now when they say just sine of x and cosine of x, they don't care if it's sine squared of x. They would care if it was sine squared of 2x. So kind of keep that in mind as you go. So sine of 3x, I used the sum and difference identity for sine, and I took that 3x and rewrote it as 2x plus x, and left cosine of 2x as cosine of 2x. From there, I used my sum and difference, and I rewrote it as sine of 2x cosine of x plus cosine of 2x sine of x, and then just brought along that cosine of 2x. So this step right here, that is just your sum and difference. That's what we use there. From there, I saw that, well, now I have all these double angles, and I can make my double angle substitution. We don't have triple angle substitutions, but we have double angle substitutions. So I went ahead and I took out sine of 2x, and I replaced that with twice sine of x cosine of x. Bring down your cosine. And then I have cosine of 2x that I need to replace as well. Now in your instructions it says it just wants it in terms of sine and cosine. So the reason, pull this guy up for a second, these are our possible substitutions. There were 3 different ones I could pick for cosine. I went with this one because it was just in terms of sine and cosine. Since it said that the expression didn't really want anything besides sine and cosine, I tried to stay away from using the ones. So that's the only reason I made that substitution. That doesn't mean it's quote-unquote correct, but it was the one I decided to do. Just like when you did proofs at the beginning of the chapter, there's no way to guarantee that this is necessarily the right way versus the wrong way. So I made those substitutions. Those are both in red. And from there, these two guys are actually the same stinking thing. So this is twice sine of x cosine squared of x. When you distribute out that sine, you end up getting, hold on, sorry, I couldn't read my own handwriting. So from here we distribute out the sine, so that became sine times cosine squared of x. And then sine of x times sine squared of x gave me my sine cubed. And really on this part just drop the parentheses. So these guys are the same stinking thing, so I combined those into one, and then just brought everything else down. There's really not a whole lot else that you can do. So this is it in its simplest form according to your book. These are kind of hard problems because there's not necessarily going to be a right answer. You're going to look in the back of the book and say, well, my answer's kind of off, but as long as you're in terms of sine and cosine, and you don't have any double angles hanging out in there or triple angles, you're probably going to be okay. Now I need to go back and talk about, there was one other one that that guy I accidentally forgot to talk about him. So this was example 2. So what's a little weird about this one is we didn't talk about double angles with the reciprocals, but what we are going to do is we're going to change this to 2 over sine of 2x. And we're going to want that to match, and what I would do is I'm going to go ahead and change this side into 1 over sine of x times 1 over cosine of x. That's kind of where we're trying to go. So we're going to use these identities again to kind of get us there. Now at least with sine of 2x, there's only one substitution you can make. Your 2's are going to go away, replace it with a 1. And it looks like we have those 2 signs that match. Technically, we probably should go back to our original, so what we're going to do is just replace these with their reciprocals. And boom, done. But this is one of the nice things is I can take this, use the reciprocal identity, and kind of flip it, so we have this, and then replace it and just kind of work and focus on the denominator.